All right. Hello, y'all. So tonight we're going to be doing some stoichiometry practice. And to do some practice, I've given us one of my favorite equations. It is the equation for photosynthesis. When you have your wonderful little plants with their little leaves, and I can't draw. When you have your wonderful little plants, they undergo photosynthesis. They take in water and carbon dioxide, and they produce glucose, sugar, and oxygen, which oxygen we kind of need to live. So I'm really happy our plants do this. So what we're going to do is I've set up a little question for us. So if we add 25 grams of water to a plant that undergoes this above photosynthesis reaction, how much, one, or how much A, CO2 is used, B, glucose is formed, C6H12O6, and CO2 is produced. Now, here's the deal. I want all of these in grams. So if you watch the previous YouTube video that I made on stoichiometry, you'll know that we'll be converting grams to grams. And so what we're going to do is honestly get started. But the first thing, the absolute first thing we need is we need to, and I'm going to star this, balance our equation. Balancing our equation is crucial to any stoichiometry problem because if we don't have a balanced chemical equation, then there is no way that we can convert from moles of one thing to moles of another. Because I actually have my stuff right up here. We use our coefficients from our balanced equation to convert in the moles to moles section. So I'm going to go ahead and just grab our little chemical equation, duplicate it so that we can get started. So we're going to balance our equation. For those unfamiliar with my balancing method, I like to make a little column chart and put all the elements that are found on both sides of our chemical reaction. We have an H, an O, and a C. And now we have O again, but we've already got it. And we have the same on the other side. So what I'm going to do is count how many of each we have on first the left side. So I'm going to focus on the left side and the left side of the equation. All right. So I see that I have two hydrogens because of that two right there. I have 1, 2, 3 oxygens, and I have 1 carbon. Now on the right side of my equation, so on this side, I see that I have 12 hydrogens. I see that I have 6 plus 2, 8 oxygens, and I have 6 carbons. Cool. This is a great place to start. As I balance, I like to balance first from the top and work my way down. And what we're going to do is look at both sides and figure out which one can be multiplied by any number to get the other. So what do I mean? Well, I mean 2 can be multiplied by 6 to get 12. And that would make our hydrogens balance because 12 and 12 are the same number. Now, what do we do with the 6 we just found? Well, I'm dealing with hydrogen and I'm looking at the left side of my equation. So I'm going to try and find hydrogen in either of my reactants. Oh, well, it's in this reactant. So I'm going to take my 6 that I just used. So I'm going to take the 6 I just used to multiply and put it right in front of where hydrogen is, or right in front of the reactant containing hydrogen. All right. So now I can redo all my math and find out that I have 12 total hydrogens. But the problem with that is this 6 also applies to that oxygen. So now I have 6 oxygen here and 2 oxygen here. So I actually now have a total of 8 oxygens. Oh, well, that's fantastic because now our oxygens are balanced. So I finished hydrogen, I finished oxygen. So now I'm just going to hop on down to carbon because carbon's the last one. And I see, just like with hydrogen, I can multiply our left side by 6 and that's going to give me 6, which is balanced. So I'm going to go ahead and take what I multiplied by and move that right in front of the thing that has, oh, sorry, I'm going to be using green, the thing that has carbon. So I have 6 water plus 6 carbon dioxide makes glucose and oxygen. Now, the only problem is, once again, this 6 doesn't only apply to the carbon, but also the oxygen. So now I have 6 times 2, 12 oxygens, plus another 6 oxygens there. So 12 plus 6, that's going to bring me up to 18 oxygens. All right, well, I'm no longer balanced. And the problem is right now I actually don't just have 8 oxygens on the right, I have 6 coming from one and 2 coming from another. So when this happens, I kind of like to break up my numbers a little bit and see that I have 6 plus 2. And then what I want to do is try and multiply either the 6 or the 2 by some number so that I can then total 18. And something I want to look at is, if I put any coefficient in front of here to affect the 6, I will also affect the carbon and the hydrogen. So really, I'm looking for a coefficient to affect the 2. And well, as fate has it, it's also 6, because 2 times 6 is going to be 12, making our total 12 plus 6, 18. So I'm going to take that 6 and move it right up there. And our final balanced chemical equation is as states. 6 water plus 6 CO2 makes 1 glucose and 6 oxygen. So what I'm going to do is go ahead and copy this one more time. And we're going to get started on the actual stoichiometry. 6, 6, nothing, and 6. Now, one quick reminder is that this nothing is not actually a nothing. It's this hidden 1, because if there is no coefficient, 1 is a coefficient. All right, time to actually get started. We have 25 grams of H2O, and we want to find how many grams of this, how many grams of this, how many grams of this. So a good hint is that as we go from grams of water to grams of each of these other things, we can use our mole island diagram. So I'm going to pull that up again. Oops. Just bring one up here. Oh no, looks like I got everything. All right, so we have our mole island diagram, and I'm going to zoom in here. We're going to be going in every single one of our reactions. We're going to go from grams of one thing, being water, to moles of water, then to moles of something else and grams of something else. But all three of our problems are going to start with grams of something to, sorry, all three of our problems are going to start with not grams of something, grams H2O to mole H2O. So the first part of our problem for all three of these is going to be exactly the same. And what you may realize is that all of stoichiometry is literally the same thing over and over and over. We're just doing the same conversions. So I'm going to get this out of my way. And we're going to just get started. So we start with what's given to us, 25 grams H2O. Every single time, start with what's given. Now, using our mole island diagram, our first conversion is going to take us down from grams of something to moles of something. And that's 1 mole of A, which in our case is H2O, over the atomic mass. So our first conversion is 1 mole H2O over the atomic mass in grams of H2O. That atomic mass, real quick, hydrogen is about 1, oxygen is about 16, but we have 2 hydrogens, so it's about 18 grams per mole. So 18 grams per 1 mole. That's exactly what I put here. So that's the first part. Then we're going to go ahead and run into our second parentheses, which is going to take us moles of B over moles of A. So you'll notice the moles of what we're starting with is on the bottom. So right here, the moles of what we're starting with is on the bottom. So I'm going to go ahead and put that there. So our second parenthesis is moles H2O on the bottom. And if we go all the way back to the first video, the coefficient from the balanced chemical equation is what's going to be our number right here. So we use the numbers from the coefficient. So I'm going to go to my balanced chemical equation, and I see that my coefficient is 6. So I actually know this is going to be 6 moles of H2O. Before I move on to the next part, where I will be going to either CO2, C6H12O6, or oxygen, I'm actually going to instead save myself quite a bit of time by copying everything I just did twice. And the reason I'm doing that is because if we're starting with 25 grams of H2O, it's not going to change. These first 3 steps are not going to change. So we can go to mole of CO2, mole of C6H12O6, or mole of O2. And we're actually now going to solve all 3 problems at the exact same time. So our coefficient for CO2 is 6. Our coefficient for C6H12O6 is 1. Our coefficient for O2 is 6. Now our last step, we are converting moles of B over to grams of B, because I asked for grams. So we're going to now have the atomic mass on top and 1 mole of whatever we had are going to on the bottom. So on the bottom, we have 1 mole of whatever we went to, so CO2, 1 mole of C6H12O6, 1 mole O2. And then finally on the top, we're going to have our atomic masses. So carbon's about 12, oxygen is 16, but we have 2. So that's going to be 32 plus 12. So this is going to be about 44 grams of CO2. That's our atomic mass of carbon. For our atomic mass of glucose, this one's going to be a little hard to calculate, but this is 12 times 6, because we have 6 carbons, plus 1 times 12, because we have 12 hydrogens, plus 16 times 6, because we have 6 oxygens. Again, 1 is the weight of hydrogen, and 16 is the weight of oxygen. Granted, I've done this enough that I'm pretty sure it's around 160 grams for C6H12O6. And lastly, for oxygen, oxygen is 16. 16 times 2 is 32 grams O2. So I'm going to go ahead and type this stuff up into my calculator. And as I type this into my calculator, something to keep in mind is everything on the top, you're going to multiply. So this is going to be 25 times 1 times 6 times 44. Everything on the bottom, you're going to divide. So you're going to divide your answer by 18, divide that answer by 6, and divide that answer by 1. If you want to be efficient, you can cancel out the 6 and the 6. You also may want to cancel out your units. Grams of water cancels with grams of water. Moles of water cancels with moles of water. Moles of carbon dioxide cancels with moles of carbon dioxide. And when we do all of our math, when all is said and done, we get about 61 grams of CO2 is what's going to be used. Once again, for the problem below, we'll go for grams and grams, moles and moles, moles and moles, so we can cancel out all our units. This time we can't quite cancel out our 6 and 6. Whoops, turned off my calculator. Oh, calculators just said, give me just a moment. All right, so this second one, 25 times 1 times 1 times 160 divided by 18 divided by 6 should come out to somewhere around 37 grams of C6H12O6. And last but not least, for oxygen, our grams of water cancels with grams of water, moles of water cancels with moles of water. 6 will cancel with 6, moles of oxygen will cancel with moles of oxygen, and we'll be left with, in our calculator, 25 times 1 times 32 divided by 18. And all said and done, that should be equal to somewhere around 44.4 grams. Oops. 44.4 grams of O2. And that's how we do all our stoichiometry. Like I said, this is dimensional analysis. So one thing I want y'all to take note of is we converted grams to moles of water, moles of water to moles of carbon dioxide, moles of carbon dioxide to grams of carbon dioxide, and our answer was grams of carbon dioxide, the only unit that wasn't canceled out. And we can do that for every single one. So I hope this helped y'all, and have a great day.